Today's topic is laws of algebra. The first problem, without using a truth table, we have to prove the left hand side equal to right hand side. First, I will take the condition to be left hand side. When I take it, so we have to apply the whatever law and bring the right hand side. P is conjunction to Q. So first I will apply here. In this part, I'm going to apply a associative law. It's nothing but when I change the bracket, it's called as associative law. So the bracket is backward, that we are going to change the front first two element bracket. A is conjunction to A is conjunction to B. I'm going to change the bracket in that. Yes, I have changed it. After I'm changing, okay. So write that statement and write the name of the law, associative law. Next step, proceed on. Okay. P is conjunction to P is nothing but same P. It is called as idempotent law. Next step, I'm going to change. I'm not doing anything. Negation P, dissection to Q, and conjunction to P. P is conjunction to P only. I'm writing single P. So P I have written. It is called as idempotent law. What is that law? I have mentioned it. Afterwards, I'm going to use a commutative law. Commutative law, it's nothing but A is conjunction to B means B is conjunction to A. Interchange the elements and write. That only I have written. This is A, this is B. As usual, I'm going to write this here, this element here. It is called as a commutative law. Next step, what I'm going to do, I'm going to apply a distributive law. What is your distributive law? Means, for example, when I have A is conjunction to B, when I have elements, okay, some C, okay, I can write it as A is conjunction to C, again conjunction to B is conjunction to C. This is one way. One more I can write it. Like this also I can write it. Anyway, you can use any one. So in this, what it is, which way it is, we have to apply. It is called as a distributive law. So distributive law, when I apply it, you check this full element. Okay, this full element is considered to be A. Okay, this fully A. Okay, A is now in this format it is. A is conjunction to B, conjunction on C, so that I can split and write A to B and A to C. So that only I have written A to B, A to C. I did not do anything. As usual, I kept the symbol as it is. Okay. So that is called as a distributive law. After a distributive law, in both the sentence, I'm going to in the first, this underlined sentence, I'm going to apply a commutative. Commutative is nothing but this. I'm going to apply a commutative. Commutative is A to B, B to A. So when I write it, negation P, conjunction to P, conjunction on Q. Only that, interchange that and written, remaining question as it is. Afterwards, I'm going to apply associative, change the bracket. Associative, change the bracket. First two element bracket. In this also, the last two element bracket. If I change, what happens means, negation P, conjunction on P is nothing but F, using complement law. See, I have written using complement law. Same way, Q, conjunction on Q, you will get the answer equivalence to same Q only. It is called as idempotent law. It has been written. Next, this fully F. F is conjunction on Q, dissection on P, conjunction on Q. So it is like this fully as F. Okay. So it is called as a dominant law. Same dominant law. How can I write some F versus something? I can write it as that element also. It is also called as a dominant law. Okay. So right hand side we have proved. So F conjunction on Q. Same way I will prove one more question. Second problem. So here some question has been given left and right. What I am going to do for this? First I will take left hand side. Is condition like this. Condition given means the symbol is connected with disjunction or conjunction only. But condition given means change that. Then you have to write it. For the change, how I have to change, I will tell. For that reason only this problem has been taken. So P is condition on, Q is condition on P. So when I have it like this, how I can write it means it's called as the property, equivalence property under condition. You can check in textbook or book also. So many formulas are there. Only you remember one or two formulas, that is enough. Okay. So what is that formula means? Some variable. Okay. Some variable P is condition on Q. How can I write? It is equivalent to. How can I write means negation P. Okay. Disjunction on same Q. Okay. Suppose Q is condition on P means negation Q, disjunction on P. Only the first variable negation, that you remember. It's called as a equivalence formula for condition. Condition you have to change, convert it as a disjunction or a conjunction, like that you have to convert, then only we can use that formula. So now I'm going to write it. So same way, negation P, disjunction on the same Q. Q now I'm going to consider this full element. So it's nothing but Q is condition on P. Okay. Now again equivalence, equal to you should not write, it is called as a equivalence. Okay. Now again Q is condition on P. This is our element. Okay. Completed. Okay. Now apply a commutative and associative law. I am going to apply it. Okay. Commutative first I will apply. Commutative is nothing but interchange the symbol. P negation Q. It's a commutative law. Next, I will change this bracket. It is called as an associative law. Okay, completed. Now, negation P and P are called true. When? It's called complement law. Complement law. Which is again true versus negation Q. It's nothing but true by dominant law. The same way, right hand side we have to prove. Okay. Right hand side we can prove it. So I'm going to take right hand side, negation P is section 2 Q condition on P. Okay. So same thing when I take it. Okay. Now what is our condition rule? Condition Q condition on P. What is the condition rule? Whatever this parameter you have, opposite. Correct? So it is nothing but P is negation to P condition on Q. Now P is section 2. P condition on this is nothing but negation P restriction on Q by equivalence, that you have to write every time. By equivalence, it's nothing but P condition on Q, it's equivalence to negation P restriction to Q. So that reason only we write it. Next step, I will change the bracket associative. So P is disjunction to negation P versus Q. It's a associative. Next step, this is nothing but true versus Q is a complement law. True versus Q is nothing but same true by dominant law. So completed. Both are true. So it is equal only. It is equivalence only. Then we have one more question, the last question. Third problem. What it is asked means, prove the following equivalence by providing the equivalence of the dual. Okay, dual. First they are asking, write the dual of this. That they are asking to prove it. Okay, first I will write the dual. What is the dual of this question? I am not changing only the symbol. See here, only the change in the symbol. That is called the dual. Completed. Next step, we are going to prove this. Okay. So how I can prove? First step, I will apply. This is my big question. So in this, I will apply distributive law. So negation as it is, negation P dissection over Q dissection on conjunction on negation Q. It's nothing but P Q as it is. Okay. So it is called distributive law. So what I have applied in this only. Why I applied? Check now. How I have applied means Q. Okay, negation Q, negation P same. It is like a A. Okay, dissection on B. A. How can I write this A with respect to the symbol? This only I have written in this case, split and written. Okay, so split it is given, I have joined, so it is called as a distributive law. Okay, next step what I am going to do, we know that this Q and negation Q are F, using what it is, complement law. Negation P is nothing but F, okay, by complement law. Next step, what I am going to do, we know that negation P distinction of F is nothing but negation P itself. So using identity law. Is what? Identity law. Using identity law. Okay. Identity law. Okay, completed. Next, negation. Negation means only P. P versus P is a dissection to Q is nothing but P. Same P itself. It is called as a absorption law. So we have completed